Welcome to screencast session on week 6, making that union find data structure. So here the two parts of implementation. First we are building a new data structure, it's called union find data structure. Then in the part 2 we are implementing the Kruskal algorithm. So with the help of that union find data structure. So let's do the part 1 implementation of this. So that we are defining a new class. The class name is that class, maybe you can make it union find, that name of the classes in this. So as usual we are writing a constructor which is for initializing def, that initializing, so that self of the particular data members, we do the initialization. So that initialization includes that various kind of data members. So let's do that. Most of them are dictionaries here. So we have a component, so which is empty dictionary, and we have members, and we have that one more, the size tracking every time. So what is the size of my all vertices are located inside a component. So these things are ready. So then we do that, making a singleton component. That's first member function we are trying to make it a method or member function, so that it contains that def, so make union find. So singleton, so the singleton, it means that each of the particular vertex, it belongs to one component of itself. So it takes that vertices as a parameter, and then we do that singleton for vertex v inside of your range of that vertices what you sent as a parameter. So now we try to make it so self-defined component, so that each v, it belongs to that same particular vertex, whatever v it was there, same kind of, because 0 belongs to the 0th component only, 1 belongs to one component. So let's do that. The members also, it contains that vertex, sorry v, because v is nothing but the vertex, and it is also that, because so each component, it belongs to the same singleton, and similarly the members also belongs to the same. So initially the size of the each component is a singleton, so absolutely the size it belongs to that v is, it is 1. So this is for the function 1 or method 1. Now we are trying to implement that function number 2. It's a one unit of operation, just finding, that is def find. It's taking that self and vertex. So whatever the vertex you sent as a parameter, which component it belongs to, that it is returned. So that is simple kind of returning, that is components of vertex which has been you are trying to trace out. So the vertex, it belongs to which component, it returns. Now it is the interesting function is that combining the components or making the union of components. So let's do that. That's union operation, which is a core operation and important operation we are implementing. So that is, we are trying to make that u to v or v to u. So that's what we want to do that. So we are making it is old and a new component which you want to merging or union of that each other. So that is components of whatever that u, so that's considered maybe as a old, and then similar lines we are trying to take that v as a new component, so that is v, and this is new component. So then after it, always we try to add the smaller components to larger size of component, that's a greater size of component. So let's do the checking of it. If the self dot size, that it is new component, if it is greater than or equal to old component size, so that is maybe sometimes equal because it's a singleton. So self dot size, it's a old component, that's that size of that old component, that could be that c old. So maybe whenever singleton, it's going to be the equal. So then we try to merge that. So new component size is bigger, so that's new component is considered as bigger because you said it is greater than or equal. So then we try to merge it. So how to merge it is that there is a traversing we do for x inside of your old components, that's whatever members are there inside of it. So all we are trying to extract it, self dot members. So whatever available inside your old component, each one we are trying to trace out it. So then we try to do that merging job, that is self dot components, that x is there, whatever x is available, that we are trying to make as a new component. So it goes to that X belongs to the new component now instead of old. So similar way, the members also, the same thing we take it. So the members also we are trying to make it appending. So the members also it is extending. So the members of the new component now it is extended size, because whenever new component is added, so the size is going to be extended, and as well as that appending job has to be done. Whatever new component is added, that's going to be appended. So bigger size of members is, so then the size is automatically it is increased for the new component. So that's do that. So the size of that new component is going to be increased. See, new is going to be increased to +1. So that as and when a old component is merged to the new component. Similar lines it happens that new component might be merged to the old component. So that's going to be the reverse of it. The same thing we are copying. So the same thing it is. So wherever old is there, we try to replace with new and vice versa. So it's going to be that else part. I did not write that entire one. So where it is the same, whatever that old component is bigger, that's going to be that. So whenever, so old component is bigger, so the component is bigger, so then what you do that we are trying to extract from that new component each of them, and we are trying to merge with old component, so that now old component is considered as component of X, and as well as that appending of into the old component, because old component is bigger, always smaller component is going to be merged with bigger component, and size of the old component is increased. So this could be the part 1. So whatever the data structure you made, that with the help of this data structure, the Kruskal algorithm, you can improve the complexity. So using the union-find data structure, that we are going to learn in that part 2. So thank you very much. Have a nice day.